Okay, now let's go and understand the intuition of a merge sort algorithm. So just like the case of an insertion sort, we have taken an example, right? Let's take an example so that we understand this intuition much better, right? Let's start here. So imagine I have an array A. So in the first cell, I have an element 6. Second, we have 5, 3, 1, 8, 7, 2, and 4. And the indices are 1, 2, 3, 4, 5, 6, 7, and 8. So these all are my indices of these elements. And this is my input array. Let's call this array is A, right? And which is of size 8 here. Now, how does this merge sort algorithm works? So the first thing the merge sort does is break your array into two parts, right? So this is my first part and this is the second part, right? So it will make the two equal parts or roughly equal parts, right? Since I have an 8 elements are present in an array, I will break them into two parts, right? So this is the first part and this is my second part. Now I have the two sub-arrays. The first sub-array contains the elements are 6, 5, 3, 1. So this is my first sub-array. And in the second sub-array contains the elements are 8, 7, 2, 4. Right? I have broken this array into two sub-arrays, each of size 4. Now I continue breaking these arrays further. Since each array has 4 elements, I can further divide it into two sub-arrays of size 2. So I get from the first of, I get 6, 5, and in the second of, I get 3, 1 here, right? And instead of 8 elements, if I had 9 elements, that is an odd number, then one sub-array would have 4 elements and the other would have 5. That's perfectly fine. We just try to make them roughly equal in size. Now, I can break these further into single elements. So again, I'm just dividing this array into two equal parts. So the first of contains 8 and 7 and the second sub-array contains 2 and 4. Now again, I'm going to break these further into single elements. So in this case, you are going to get 6, 5, right? And here you are going to get 3, 1. And here you are going to get 8, 7, right? And here you are going to get 2 and 4, right? So what I am doing here, I'm dividing my array step by step. First I had an array of size 8, then I divided into sub arrays of size 4, then again I divided the sub arrays of size 2, and finally the sub arrays of size 1. So this is call it as the divide stage of the merge sort algorithm, right? Now let's come to the second part, right? Let me write it down here. The second part of this algorithm is the conquer stage. Let me write it down here. The second stage is the conquer, or I would say the merge stage of an algorithm. So at this point, I have an array of size 1, right? So let me write it down here. So 6, 5, right? 3, 1, 3, 1. Then what we have 8, 7. Then we have 2 and 4. So these are the elements are present in each sub-array. Now I start merging them. Since each pair has only one element in each sub-array, merging them is very simple and straightforward one, right? So for example, for 6 and 5, so what I'm going to do, I'm going to pick the smallest element from these two and I'm going to place it in my new array of size 2 here. So the new element 5 will come here because out of these two, 5 is smaller. So 5 will be placed it first, then the large element 6 will place it here. So I get 5 and 6. Similarly for 3 and 1, so I'm going to perform the merge operation and I'm going to create a new array of size 2, right? So in this case, 1 will comes here and 3 will comes here, and I'm going to apply for these two elements as well. So in this case, 7 will comes first, then 8 will comes next, Lastly, we have 2 and 4. 2 comes first, then 4 will come at the last. Now I will move one level up. I want to merge these two, right? So here we have 5, 6 and 1, 3, right? Now let's call the first array is B. Now let's call the second array is C. Let's see, right? And also I'm going to create the 2 pointers, I and J, right? So I pointer will represent the first element of my B array, and the J pointer will point into the first element of my C array, right? First element of B, and J is pointing to the first element of C. Now I compare BI with CJ, right? So that means I'm comparing 5 with 1. So which element is smaller? 1 is smaller. So what I'm going to do, I'm going to create the new array of size 4, right? And the first element will be placed here. So 1 will be smaller. So I copy 1 into the final array, which is this array. And what I'm gonna do, I'm gonna increment the value of J by 1 because this element is already processed, right? So that is the reason I'm incrementing the pointer of J by 1. Now the J is pointing to the second element of my C array. Now again I will compare BI with CJ, 5 with an element 3. So obviously 3 is smaller, right? So I copy 3 and place it here, right? Now I will increment the value of J by 1, right? Here we reach the end of an array, right? So there are no more elements in C. So one common trick here is to append one hypothetical element. So let's say the hypothetical element, call it as the infinity at the end of each array. So this is the simple hack or trick we will use it, right, for comparing the two subarrays. So obviously the infinity is greater than every real number, or I would say very large number. I'm going to keep it. For just understanding purpose, I just keep the value as infinity. Now again, I will compare BI with CJ. So in this case, 5 and infinity, 5 is smaller, and I'm going to copy 5 into the new subarray. Then I will increment the value of I by 1. So now I is pointing to the second element of my B array. Again, I compare BI with CJ. 6 and infinity, 6 is smaller, and I'm gonna place 6 here. So after merging these two subarrays, I got the new array of size 4, which contains the elements are 1, 3, 5, 6. Now using the same strategy, right, I'm going to merge these two subarrays as well, right? So in this case, again, I'm just assuming this subarray with a name as B and this subarray with a name as C. So again, I'm going to take the 2 pointers IJ. I will be pointing to the B array, first element of my B array, and J is pointing to the first element of my C array. Again, we'll repeat the same process. After merging these two subarrays, so what I will get, I'm gonna get the elements are 2, 4, 7 and 8, right? Now I have the two sorted arrays of size 4, 1, 3, 5, 6 and 2, 4, 7, 8, right? Now I will merge them again using the same process, right? So I'm making to assume this is my B array and this is the C array, and I also am going to take the 2 pointers IJ, and also I'm just taking some hypothetical element will be added at the end of the array, that is infinity, right? So initialize I and J at the beginning of both arrays, and also I added infinity at the end of the both arrays for simplicity, right? Now I'm going to merge these two sub arrays, right? So I'm going to place the elements in the final sorted array. So compare 1 with 2. So I'm comparing BI with CJ. So which element is smaller? 1 is smaller. So I'm copying 1 here into the new sub array or the final array and increment the value of I by 1. Now I is pointing to the second element of the array B. Now compare 3 with 2. 2 is smaller. then copy 2 and increment the value of j by 1, right? Now j is pointing to the second element of my new the array C here. Compare bi with cj, 3 and 4. Compare 3 and 4. 3 is smaller, copy 3 into the new array and increment the value of I by 1, right? So now I is pointing here. 5 with 4, 4 is smaller, and copy 4 and increment the value of j by 1. Now j is here, right? 5 and 7, 5 is smaller, I'm just copying into the new array and increment the value of I by 1. Now compare 6 with 7, 6 is smaller, and copy 6 into the new array and increment the value of I by 1. Now I is here, right? Compare infinity with an element 7. Obviously 7 is smaller, I copy the 7 into the new array and increment the value of j by 1. Now j is pointing to this element. Infinity and 8. Compare infinity and 8. 8 is smaller, and I'm going to copy this element to the new array and increment the value of j. Now here I reach the end of the arrays. Now both pointers are pointing to infinity. So in this case, I will terminate this. I will stop the process, right? So this is my final sorted array. So the final sorted array contains an elements are 1, 2, 3, 4, 5, 6, 7, 8. So that's how the merge sort algorithm works. So the addition of infinity is just a programming trick to make comparisons easier. So there are other ways to implement the merge sort without adding an infinity, but this is the neat and simple hack to compare the two subarrays. So the most important lesson here is that we started with a big array, right, and broke them into smaller arrays until each array had only one element. Then we started merging them step by step, right? First we merged the array of size 1 to get the array of size 2. Then we merged the arrays of size 2 to get the arrays of size 4. And finally we merged the arrays of size 4 to get the final sorted array of size 8. So this is the intuition behind a merge sort algorithm. So in the entire algorithm, there are the two main steps or the stages. The first stage is divide stage and the second stage is the conquer stage. So what have we done? We took the big problem and broke it into very smaller problems. Then we merged the solution of the smaller problems to solve the larger problem. So this is the whole idea of the divide and conquer strategy in the data structures and algorithm. And before we go into the analysis, first we will look into the pseudocode, same like how we have seen it for insertion sort, right? So we will look into the pseudocode in the next video and understand how to implement this in the code. That is the very interesting and the fun part which we are going to